Okay guys, so this is a short video of how to do the titration. After you've prepared your copper standards and your brass unknowns, you should have solutions that look like this, although the unknowns might be slightly different because they do contain other metals than just the copper. When you process each of these solutions, you should do them one at a time and not overly quick, but just make sure you get it done because you don't want to dilly-dally. The generation of the iodine can be a problem, and you don't want to lose it and get an inaccurate endpoint. So to that end, go ahead and make sure you have everything you need to do the titration. And one of the ways I do that is to measure everything out ahead of time, and you can do the same. So over here I have my reagents that I need. This is my potassium iodide. This is my starch solution. You don't have to put it in one of the little whey boats, but you can do that obviously. And then this is potassium thiocyanate. And so I've got them all ready to go, so I can start my titration. So what I want to do first is add the potassium iodide, and what will happen is the reaction between the copper and the potassium iodide generates initially a green and now a cappuccino color solution. So what we've got in here is precipitating copper 1 iodide, and then the triiodide ion, which is iodine plus I minus, and that's what the color, the chocolatey color, is. And so what we're going to do, we're going to titrate this towards a solution that has basically a white precipitate at the bottom with a light yellowish color to the supernatant. And then we're going to do the next step. So let's go ahead and start titrating. You may be able to see, as I let the titrant into the middle of the solution, that it starts getting white where the titrant is hitting, and that's the white precipitate we're looking to see at the bottom of the flask. And this is going to take the majority of the titrant volume that you're going to get to your equivalence point, but it doesn't get us all the way. And so we have a couple of other stages that we have to do, but we have to finish this one first. So why don't I stop right here and let it settle, let the precipitate settle out. And what we're looking for is the supernatant solution above the precipitate to really not have the reddish brown color. And let's see. Not sure if you can see that very well on the video, but it's still got quite a decently dark color to the supernatant, and we want it lighter than that. So let's keep going. So now you see it's getting lighter and lighter. You can see that the white color is now not disappearing very fast. So we're closer for sure. Let's see where we are now. Again, the supernatant can have a little bit of light yellowish color to it, but not brown. The difference is the brown is the triiodide ion, and the light yellowish color is actually more of iodine. Now, this still has a little bit too much redness to it at this point, so a little bit more. Let's see where we are there. There we go. You can probably see there that the supernatant is a little bit more yellow than it is red. So we're about the right point to add the starch indicator, which is going to allow us to better visualize the remaining iodine that's in the solution. As you can see, when you add that, you now have a solution that not only has the residual yellowish color, but it now also has this blue purple complex of the triiodide ion with the starch. And so now we're probably only a couple of mils away from our equivalence point, so we want to go slower. And we do not want to get rid of all the triiodide color. One of the problems with this is if we go too far, we may not actually see the end point. The reason is we have to do one final step and release some of the iodine that is trapped on the surface of the solid in here so that we can titrate it. And if we do things wrong, we won't see when that really happens. So we're trying to get this so we get the majority of this color disappeared, and then once we do that, we'll only have a couple more drops left to finish the titration once we add the potassium thiocyanate, which is what's going to release the trapped iodide ion. Okay, we're looking for it to lighten significantly on one drop here. And obviously it's better to take your time than go too fast. So my apologies that the video will be a little longer, but getting pretty close now. Okay, we're very close. I say we're there. So you can see it's lightened significantly now, but there's still some purple color to it. So now what I'm going to do is add potassium thiocyanate and swirl for a good 15 seconds, and what you see is, hopefully, that the purple color has increased because we've now released the trapped iodide that was on the surface of the solid, and it's now in solution, able to complex with the starch. And once we get this in solution, after having swirled for 15 seconds or so, now it's probably going to be just a couple drops here until we're finished. So I'm going to add one drop, see where we go. Depending upon how close to how light you got it in the previous step will depend on exactly how many drops it takes you for this step. And of course, it's a bit of an art to judge. So let's see, this is my third drop. And we're looking for basically a white, just a solution with the white precipitate in it of copper iodide. And we're very close, as you can see right there. We've probably got just a half drop to go here, because I still see a little bit of color to this. So let me add my half drop. And there we go. So the solution color here is basically white with a slight tint to it, maybe a little bluish tint, maybe. You know, if you're not sure that that's the end point, of course, you can go ahead and do one more drop or half drop. And if you see any difference, wasn't much difference there, then you're done. Okay, so that's it. That's how to titrate with the copper with thiosulfate.